Welcome to the skies over Longmont for June 2020. I'm staff astronomer John Ensworth with Longmont Public Media and Cherrywood Observatory. Astronomy news this month. We have comets in the news. We had two really good comets, for astronomers at least, approaching the sun in May, heading into the beginning of June here. You had to be a somewhat experienced backyard astronomer or have at least a small telescope or some binoculars and know the time to go out and the direction to look to see these comets. They were great as comets go, but they're not the kind of comet that everybody just sees going out and looking up into the nighttime sky. 2007, Comet McNaught was so bright that I could see it from a bus stop in Washington, D.C. after sunset. The sky was still bright and you could see the tail and part of the comet's head, and it was amazing, and no one around was noticing it. I was trying to point it out to people. Look, comet right over there. Comets are dim and they take a little work to know where and when to find them. But Comet SWAN, as comets go, was a pretty good one, heading into early morning sky and into the twilight hours. This picture here is taken end of May, and you can see the sky starting to brighten with sunrise already. This is a longer term exposure. You can see the motion of the Earth in these trees in the foreground, with the comet and the stars being held steady in the background. It's going to get dimmer and closer to the sun and harder to see. Comet Atlas, we talked about last month, broke into a number of pieces. Those pieces have sort of coalesced back together. Gravity has very slowly tugged them back into kind of one comet. Again, you had to know where to look and how to take an image or to see this comet. There's a good clickbait title, Pluto's Collapse. It's just the atmosphere we're talking about, and it's not much of an atmosphere. To give you some background what's going on here, Pluto goes around the sun in about 248 Earth years. It was last closest to the sun in 1989, and it will be out at its most farthest distance in February 2114. In a way, Pluto acts like a comet when it warms up. The frozen gases on the surface vaporize and create a bit of an atmosphere. This is 1/10,000th the pressure of Earth's atmosphere at sea level. We're very close to a vacuum, even on the best day on Pluto. As it moves out in its somewhat elongated orbit, it gets colder, and these gases return to an icy state, snowing down into the surface. What astronomers have noticed, when Pluto goes in front of a distant star, we can get measurements of this atmosphere's density and thickness. It has decreased 20% since the last measurement in 2016. We did not get a comparable measurement from the New Horizons mission. We only expected a 1% drop. So this is 20 times more than we thought would happen. Now, Pluto is moving out of the galactic plane into a part of space, from our point of view, where there are many fewer background stars. It's going to be a while before we get another checkup on Pluto's collapsing atmosphere. Sunspots could be making a return. No, not yet. Let's talk about sunspots real quick. They're cooler spots on the sun. They're associated with strong magnetic storms. They go in an 11-year cycle of many sunspots down to 0 or just a few sunspots, and that can vary between 9 and 14 years. The sun, as you can see, back in the early 90s had a pretty good maximum here. In the early 2000s, another good maximum, but fewer sunspots at maximum. In the 2014-15 area, sort of had two little peaks here and many fewer sunspots. Now the sun has gone very quiet. It's been abnormally quiet since 2016. In fact, last year, 2019, the sun was blank for 77% of the time. On May 29th at 3:24 a.m., and yes, we do have telescopes watching the sun 24 hours a day. We have instrument platforms like SOHO observing the sun 24 hours a day, so we miss nothing. Our sunspot appeared, and this is a little graph here of the X-ray flux caused by the magnetic disturbance. And normally we need 6 months of observation to know if the new sunspot cycle is beginning to pick up. We had 2 sunspots appear on December 24th of last year, and they faded out. Well, I can already give you an update. That little complex already collapsed. The sun, this is not just a yellow circle here. Here's a live image of the sun the day that I'm recording this. There's nothing on there. We'll keep an eye on it, see if sunspots do start to increase again. But our next maximum, however big it may be, could occur between 2023 and 2026. We have seen century-long periods where the sun has had virtually no sunspots since the time of Galileo. It is possible we could be in for a long, quiet, sunspot-free period. Well, let's take a look at big star parties again. Last month we had a few that were still holding out that they could continue in June, but Bryce Canyon Astro Festival and the Rocky Mountain Star Stare are now canceled. Amazingly, the Bootleg Spring Star Party in Harmony, Illinois, where registration just closed a few days ago in the end of May, is still on. If you want to go, maybe you can contact folks at the website and see if they can slip you in anyways. Off into July and August, the Nebraska Star Party in Valentine, Nebraska, July 19th to 24th, is still planning to be held. The Oregon Star Party, Stelving Convention, Almost Heaven Star Party, Summer Star Party in Massachusetts, Merritt Star Quest, Maine Star Party are all canceled. The Northern Nights Star Festival in Palisade, New Mexico for August, later in August, is still on. You can go to skyandtelescope.org's 2020 Star Party update to keep an eye on anything you might be interested in. Our Astro 101 topic is the Milky Way. What is the Milky Way? Well, of course not milk. It's actually just a bunch of stars. Many, many, many stars in a big disk. It's our galaxy that we reside in. Even in this example picture here, you can see lots of stars, gas and dust between the stars, so it's darker material. And as you go away from the disk, there are few and fewer background stars and foreground stars. You can scan the whole sky and pick out the Milky Way, even if it's too bright to see. And as you do get more city lights down below, more light pollution, more haze or moisture in the atmosphere, the Milky Way is one of the first casualties. It vanishes very easily. In Longmont, I see the Milky Way in maybe the top third of the sky when it's up overhead. There's even more city lights obscuring the Milky Way. So this is an artist representation of what our galaxy kind of looks like. It's a big disk. We have the central bulge. Down in the middle we have a giant black hole. And we're out in the galactic suburbs in one of the spiral arms, about 2/3 of the way out. The entire galaxy is about 100,000 light years across. So it takes 100,000 years for a message from here to travel at the speed of light all the way over to this side. Let's take a look at the sky above your backyard for this month. The moon is just coming out of first quarter, May 30th. By June 6th, we're at full. Last quarter, June 13th, June 21st, we're back at noon. And at the very end of the month, we're back to first quarter. The planets for June, in the evening, right after sunset, Mercury is now alone. We've lost Venus, but not forever. Mercury is the closest planet to the Sun. Its greatest distance from the Sun, from our point of view, will be 24 degrees, and that does occur this month. It is in the twilight glow here in the constellation of Gemini. A NASA messenger image of Mercury up here, so it's not how it would look in your telescope. It is not exceptionally bright. This last month, Venus passed it for a few nights, and that was one of the easiest times to see it. I got the family out into the street, taking a peek at Venus and Mercury side by side. 24 degrees, if you remember our earlier Skies Above Longmont video, you get 10 degrees from the edge of your hand to the other edge of your hand when you make a fist. So 24 degrees is 2.5 fists up from the horizon. You have to be out there while it's still pretty bright, looking to the west, catch Mercury. If you go out around midnight, we finally have planets rising in the east. Jupiter and Saturn are now becoming middle-of-the-night objects to watch. Later at night, in pre-dawn, Jupiter and Saturn are down in the southwestern sky. Notice this interesting little star pattern here. This is the constellation of Sagittarius. Aquarius is right up in here, but it's not shown. It looks like a teapot. We have the top of a teapot. The spout goes right off the edge of the screen. The bottom of the teapot's here. The back teapot where the handle is closest to Jupiter. On June 8th and 9th, the moon comes sailing through here and make an interesting early dawn pattern in the southwestern sky. At 3 a.m. around June 10th, you see Jupiter and Saturn. There's our teapot shape over here in the southwestern sky. The moon will be between Jupiter and Saturn and Mars and Neptune that have just risen. These will be coming earlier and earlier as the summer goes on. Eventually you'll be able to see them without having to set an alarm clock or wake up really early. So Mars will be in the pre-dawn sky in the southeastern direction. Neptune is just to the left of Mars. Uranus comes up about 2 hours after Neptune rises, very close to sunrise, no longer lost in the glare of the sun. If you're looking for Uranus, you need binoculars, or a small telescope at least. Find the constellation of Aries, or look for the Pleiades, a little star cluster that we've talked about before. It's down here below Aries and the Pleiades, coming up out of the east. Venus is changing skies. It was a beacon of brightness in the west as we began this year. On June 3rd, it's going to pass about half of the sun's diameter north of the sun, and it's not possible for us to see. It's a daytime sky. By June 12th, it will rise about 45 minutes before sunrise. So you'll start to see that super bright star-like object in the eastern sky in the morning, and by the end of the month, it's now rising 2 hours ahead of the sun. So it'll be much higher and putting on a pretty good show. The sun, June 1st, rises at 5:33, sets at 8:22. The length of the day is about 14 hours, 48 minutes. At noon, the sun will be 72 degrees above the southern horizon. June 30th, sunrise is at 5:35 a.m., almost the same. Sunset is later at 8:31, with day length of 14 hours, 56 minutes, 73 degrees up at local noon. Between those two extremes, we get the summer solstice, June 20th. This is the maximum height of the sun above the southern horizon. The first day of summer begins at 9:54 a.m. Mountain Time. And on that day, the sun rises at its earliest at 5:31 a.m. The sunset is not at its latest. That occurs a little shifted because the Earth's orbit is not a perfect circle. It's slightly an ellipse, so we go a little faster at part of the year, a little slower at another part of the year, and that makes the sunrise-sunset times drift a little bit. This is the longest day of the year at 14 hours, 59 minutes, 15 seconds. Just a few seconds shy of a full 15 hours, and the sun is 73.7 degrees above the horizon. Our feature object for this month will be the moon itself. The moon orbits the Earth every 27.322 days, and it rotates on its axis at the same rate. That means one face of the moon is always pointing towards the Earth. This is the Earth-facing side of the moon. The back side of the moon wasn't seen until we could send cameras around in orbit to send images back. The orbit of the moon is not a perfect circle either. What is out in space? So we do get to see over time, if we take pictures or make sketches, a little more than 50% of the moon from Earth. We can get a little bit on the left side, a little bit on the right side. Because the orbit of the moon is tilted 5 degrees, we get to see a little bit above and a little bit below of center as well. This 5-degree tilt also means we don't get solar eclipse at every new moon and a lunar eclipse at every full moon. It's got to be at a node, a point where it's 0 degrees or very close to it, off of the plane of the rest of the solar system. The moon reflects sunlight hitting it. The bright part of the moon is just daytime, and the dark part of the moon is nighttime. When you're out in the evening looking at the moon, the part facing you will make that a home for our imaginary alien, a little moon creature. For the moon creature, at first quarter, that's the first time that the sun has come up in about 2 weeks. At full moon, our little moon creature has the sun high up overhead, so it's at lunchtime. Another week later, the sun is setting for our moon creature, and we're at third quarter, and it's the middle of the night for our moon creature at new moon. The day, quote unquote, on the moon almost lasts a month. It's kind of strange that way. It's just illuminated the same as we are. The moon also creates tides. The sun does too, but the moon being so much closer has a much stronger effect on the tides. You have a bulge of ocean water on the moon side and also the opposite side. It's a vector thing, and I'm not going to get into that this video. You get low tide off to the sides of the moon. You may think, who cares about the tides in the middle of the continent in Colorado? But we actually have an atmospheric tide that travels around twice a day. You can see it on a barometer if you have a way to record what the barometer sees in rising and falling pressure. And the Earth itself rises and sinks just a little bit twice a day. You're just moving along with it, and you don't feel it. Really slow, doesn't bother anybody. Your Longmont Observing Challenge this month is to begin to find the summer, or the spring-summer Milky Way. You're going to have to go out kind of late at night, 10, 11 o'clock or so. You'll start to see a dim arc of the much brighter than winter summer side of the Milky Way. This is a long-term exposure, images stitched together, so this is not how it'll look. It'll be a dim, kind of ghostly, cloudy light. Maybe go out to County Line Road 1 or out beyond Firestone and get a good view out there. Down here on the right side, in the southeastern sky, we have the constellation of Scorpius right here, and there's a little teapot that we saw in the earlier graphics. So it's the teapot, bottom of the teapot, handle, top of the teapot, and right where the steam comes out of the teapot is right where the middle of our galaxy is. This is the central bulge that we saw in the diagram earlier, and down in here someplace, Sagittarius A star. This is the black hole in the center of our galaxy in this direction. Alright, not great news yet for astronomy events near Longmont. Let's go through everybody real quickly here. Normally June 30th would be the Longmont Astronomical Society's public event, and they are canceled for now. Their open space star party at Rabbit Mountain will also be near the end of the month, and that is canceled. The Little Thompson Observatory is closed to the end of July. July is normally the month they're closed anyway for maintenance and cleaning. Estes Park Memorial Observatory also closed to the end of July. Check these websites though, see when things start to open up again. Northern Colorado Astronomical Society, June 4th, right about when this video goes out. Don't have the time confirmed, I didn't see it on their website, but Jim Baer is going to be talking about nightscape photography via webcast. And I'm sure, like previous months, that will be archived. You'll be able to catch that probably off their site or off of YouTube. If you have any additions, corrections, suggestions, please contact me, johnensworth@gmail.com. Note the music you're hearing in the background is available for commercial and non-commercial purposes. This has been the Skies over Longmont for June 2020. Staff Astronomer John Ensworth. I'm urging you to keep looking up.